In this video, we'll be looking at the first of the special types of linear transformations in matrices, which is reflection. So with all the following transformations, matrices generated based on where the points 1, 0 and 0, 1 are mapped to on the plane as a result of the transformation. These points are represented by columns 1 and 2 of the identity matrices. So 1, 0, 0, 1 is obviously going to map any point onto itself. So if we change the columns to something else, it will give us a new matrix. So in terms of reflection, a reflection is a linear transformation in which every point of the original is reflected through a straight line that we call the mediator. It's called the mediator from that root word of MED, which is like medium, median, all those words that sort of mean the middle. So the middle of the 2 points is going to be the mediator. The diagram here shows a triangle being reflected through the mediator, and we can see that all the points are equidistant from the mediator as well as being perpendicular to it. So we let lowercase m denote the reflection transformation and capital M the reflection matrix. So in the first case, if we are reflecting in the x-axis, any point on the x-axis, for instance 1, 0 here, is going to be mapped to itself. So 1, 0 becomes 1, 0, but anything off the mediator is going to be reflected, so its y component becomes negative. So seeing here, our matrix ends up being 1, 0, 0, negative 1, and we can see there that if we multiply that by x and y, x will stay the same, but y will become negative of itself. And that makes sense given the mapping that we've done here. The other case is reflection in the y-axis. So that's through the mediator of x equals 0. Point 1, 0 is now reflected, so that becomes negative 1, 0, but the point 0, 1 stays the same. So our matrix is going to be instead negative 1, 0, 0, 1. And you can see if we multiply that through by the point x and y, we get negative x and positive y. We can also reflect in terms of the line y equals x. So that is going to essentially flip our x component and our y component. So instead of being 1, 0, 0, 1, it's going to be 0, 1, 1, 0. There'll be a similar process for the reflection line y equals negative x, but our values are going to be negative instead. So 0, negative 1, negative 1, 0. So in example 19, we're asked to find the image of the point negative 2, 3. So this point right here, under reflection in the x-axis. So capital M, y is equal to 0 subscript, is equal to 1, 0, 0, negative 1. And we want to find our point, P dash, which is going to be our matrix multiplied by the point we're given. So this should be positive 1, 0, 0, negative 1 times negative 2, 3, which is going to give us negative 2, negative 3. So it's quite easy to see this geometrically on a Cartesian plane, but this is the actual maths behind it. This is what we're multiplying together to find this new point. We can't just simply look at a Cartesian plane and say, yeah, that makes sense. It's going to be the same distance from the mediator. Let's plop it there. We want to actually show this mathematically speaking. So that gives us the point negative 2, negative 3, which is going to be... sorry, I've messed up my first point. That would be negative 2, positive 3 over there. And so our reflected point would be negative 2, negative 3. Example 20 is now building upon this to be used with functions. So determine the equation of the image of y equals negative x squared after it is reflected in the line y equals negative x. So our matrix for that is going to be 0, negative 1, negative 1, 0. So x prime, y prime will be that matrix there that we've just developed, multiplied by xy. And so the two equations we get for this are x prime is equal to negative y, and y prime is equal to negative x. Now we have to get these in terms of x and y, so we get that x is equal to negative y prime, and y is equal to negative x prime. And so if we substitute that back into our original equation, negative x prime is equal to, so x is negative y prime, and then we square that, which is going to give us x prime is equal to negative y prime squared. So we can see the negative goes to the other side, and that's going to give us the following curve coming out to the left, and it's a sideways parabola. The other way you could look at it is y prime is equal to plus or minus the square root of negative x prime. And now, of course, this is only defined when x is negative, and we can see that on our Cartesian plane here. We're only working in quadrants 2 and 3, where x is negative values. Otherwise, the solution to this does not exist. So we get the fact that x is less than 0. Okay. Next is looking at a general case of reflection in the line y equals x tan theta. So you might recognize this more easily as y equals mx, because tan theta is equal to opposite over adjacent. The other way we could look at that is rise over run. So that's going to give us a gradient value. So a couple of things to unpack in these images here. In our first one, we're seeing where does the point 1, 0 get mapped to? And to do that, we have to treat this as a triangle and apply trigonometry. So we see we have our point theta. This is our line, our mediator. So this is our mediator here. And the point 1, 0 is going to be mapped up here. Now, because the line across the x-axis here is 1, the hypotenuse of this triangle is also going to be 1, because we've just sort of rotated or reflected that line up there. So this distance is still going to be the same from the origin, from the point on the mediator, which means this angle here is going to be theta as well. So the angle we get here in orange is 2 theta, and that's going to be the angle for this triangle that I'm outlining here. So to find the y value of this triangle, that's our adjacent, and so our adjacent is equal to the hypotenuse, which is 1, times cosine of 2 theta. So our x is cosine of 2 theta, sine of 2 theta. Our y is cosine of 2 theta, and that is where the point 1, 0 gets mapped to. The point 0, 1 goes through a similar process. It gets mapped to cosine of 90 minus 2 theta and negative sine, because we're in the bottom quadrant, so this value is going to be negative. Negative sine of 90 take 2 theta, but then we have this property here, cosine of theta is equal to sine of 90 minus theta, and that comes from the fact that they share a right angle triangle in terms of trigonometry. So we can replace these with sine of 2 theta, so sine of 2 theta, and then negative cosine of 2 theta. And so our matrix will be, what have I done here? Oh, I had these right the first time. So this must be wrong. So let's fix that up. So x is going to be cosine of 2 theta. Our y is going to be sine of 2 theta. So we'll get those fixed up. And so our final matrix is cosine 2 theta, sine of 2 theta, sine of 2 theta, and then negative cosine of 2 theta. All right, so let's apply this in example 21. So determine the equation of the image of the line y equals negative x take 1 after reflection in the line y equals root 3 of x. So y equals negative x take 1, y equals square root 3 of x is our mediator. So that's the same as y equals tan of 60 degrees times x. Yes, that's right. Our exact trig values are back. Everyone's favorite. So what does this mean about our mediator? Our mediator is y equals x tan 60. So we're going to get cosine of 120, sine of 120, sine of 120, negative cosine of 120. Now, we don't know what cosine of 120 is, but we do know what cosine of 60 is. So we can treat this as, instead of looking at 120, we can treat it in the first quadrant and just change the signs. So cosine of 120 is the same as negative cosine of 60 degrees. Sine of 120 is the same as sine of 60 degrees. And so we get, that's going to be positive because it's negative times negative 60 degrees. So what this ends up being is negative a half, root 3 on 2, root 3 on 2, positive a half. And so our x prime y prime is going to equal to that matrix times x and y. At this point, if we were to multiply the matrices together, we'd get x prime in terms of x and y, but it'd be in such a way that we can't find x in terms of x prime. So in order to be able to make these the subject, we actually need to multiply by the inverse. So if we get the inverse of our transformation matrix and multiply it by x prime y prime, that will give us our x and y. And so the inverse of this matrix, it ends up having a determinant of negative 1, and so the matrix that we end up getting is xy is equal to, I think it's actually the same matrix. And so what we get from that, there's a bunch of arithmetic that's in the textbook if you'd like to have a look at that, but eventually what we end up getting is y equals root 3 take 2 x prime plus 1 take root 3. So we can see this has a y-intercept of 1 take root 3 and a gradient of root 3 take 2. So it is going to be coming down like that. I'll draw our mediator in orange and our original function in purple, which was just negative x take 1, looks like this. And so the idea here is that any point going through the mediator will come out to a new point. So they'll always be equidistant in some way. There's a much better picture of this in the textbook, if you'd like to see that. So that's the first part of this section. The second part, which is rotations, we'll be looking at in the next video.